Capacitors are fascinating components in electronics. They store and release electrical energy. Imagine them as tiny batteries. Unlike batteries, they charge and discharge very quickly. This makes them unique and useful. You've seen capacitors in many devices. They're inside your phone, TV, and computer. They help control power and smooth out electrical signals. Capacitors are everywhere, even if you don't notice them. Understanding capacitors can seem complex, but with some simple explanations, it becomes easier. Let's dive into the basics and see how they work. A capacitor has three main parts. These are two conductive plates and an insulator. The plates are usually made of metal. The insulator between them is called a dielectric. This structure is simple but powerful. The plates can hold electrical charge. The dielectric stops the charge from moving between the plates. This setup allows the capacitor to store energy. The type of dielectric material affects the capacitor's properties. Different materials are used for different capacitors. Common dielectrics include air, ceramic, and plastic. Each type has its own advantages and uses. The basic idea is the same for all capacitors. Two plates, an insulator, and the ability to store charge. This simple design leads to many applications. When a capacitor charges, it stores energy. Connect it to a battery and electrons start to flow. Electrons build up on one of the plates. This creates a negative charge. The other plate loses electrons, creating a positive charge. The dielectric in the middle blocks the flow, so the charge stays on the plates. The capacitor continues to charge until it reaches the battery's voltage. This process happens quickly. Charging a capacitor is like filling a bucket with water. The bucket fills up until it matches the water pressure. In the same way, the capacitor charges up to the battery's voltage. Once charged, the capacitor is ready to release its energy. This is useful in many electronic circuits. When a capacitor discharges, it releases stored energy that it has accumulated over time. To initiate this process, you need to disconnect the capacitor from the battery and then connect it to a circuit where it can release its stored energy. The stored electrons will then flow from one plate of the capacitor to the other, creating a movement of charge. This flow of electrons generates an electrical current, which can be harnessed for various applications. The discharge process is typically very quick, often occurring in a matter of milliseconds. In fact, it can happen in just a fraction of a second, depending on the specific characteristics of the capacitor and the circuit. The speed at which a capacitor discharges is influenced by the type of circuit it is connected to. Some circuits are designed to allow a slow, controlled discharge, while others enable a much faster release of energy. Discharging a capacitor can be compared to letting water out of a bucket. The initial flow is rapid. At first, the water gushes out quickly, similar to how the electrical current flows rapidly when the capacitor begins to discharge. As the bucket empties, the flow of water slows down, just as the electrical current decreases as the capacitor discharges. This gradual decrease in current is a key characteristic of the discharging process. The ability of capacitors to release energy rapidly makes them incredibly useful in various electronic applications. They can provide a brief burst of power to devices or help smooth out electrical signals, ensuring more stable operation of electronic circuits. Section 5. Energy storage in capacitors. Capacitors store energy in an electric field. This field forms between the two plates. The amount of energy depends on the charge and voltage. Higher charge and voltage mean more stored energy. The stored energy is not chemical like in batteries, it's purely electrical. This makes capacitors different and special. They can release energy very rapidly. Think of a capacitor as a spring. Compress the spring and it stores mechanical energy. Release it and the energy comes out quickly. Capacitors work similarly but with electrical energy. Storing energy in capacitors is efficient. They don't lose energy to heat or other forms. This efficiency is one reason they are widely used in electronics. Section 6. Energy release from capacitors. When a capacitor releases energy, the electric field collapses. Electrons move back to their original positions. This movement creates an electric current. The amount of current depends on the capacitor and circuit. This rapid release of energy is very useful. Capacitors can provide a quick boost of power. For example, in a camera flash, the capacitor releases energy to create a bright light. The speed of energy release can be controlled. By adjusting the circuit, you can make the discharge slower or faster. This flexibility makes capacitors versatile. Capacitors are like small bursts of energy waiting to be released. This makes them essential in many electronic devices. Section 7. Real-world applications of capacitors. Capacitors have many real-world applications. One common use is in power supply systems. They smooth out fluctuations in voltage. This keeps devices running smoothly. In audio systems, capacitors filter out noise. This improves sound quality. They block low-frequency signals and allow high-frequency signals to pass. This makes the sound clearer. Capacitors are also used in motor starters. They provide the initial surge of energy to start motors. This is important in appliances like refrigerators and air conditioners. Another application is in timing circuits. Capacitors can create delays in electronic signals. This is useful in many timing and counting devices. Their versatility makes them essential in modern electronics. Section 8. Capacitors in everyday electronics. You find capacitors in almost every electronic device. They are essential components that store and release electrical energy, playing a crucial role in the functionality of these devices. In smartphones, they help manage power. Capacitors ensure that the phone's circuits receive a stable and consistent flow of electricity. They ensure the phone operates smoothly and efficiently. This means that your apps run without glitches and your phone's performance remains reliable. Without capacitors, your phone would not work as well. You might experience frequent crashes, slow performance, and other issues. In televisions, capacitors improve picture quality. They help in maintaining the stability of the power supply to the screen. They filter and stabilize the power supply. This ensures that the images you see are clear and free from distortions. This allows the TV to display clear and sharp images. High-definition visuals are made possible by the efficient functioning of capacitors. Capacitors also help in managing sound quality. They ensure that the audio output is crisp and free from noise. Computers use capacitors extensively. They are found in motherboards, power supplies, and memory systems. These components rely on capacitors to function correctly. Capacitors ensure that computers run smoothly without interruptions. They help in maintaining the integrity of data and the stability of the system. They help manage power and signal integrity. This is crucial for the overall performance and reliability of the computer. Even small devices like remote controls have capacitors. These tiny components are vital for the proper functioning of the device. They store and release energy to power the device. This ensures that the remote control responds quickly and accurately to your commands. Capacitors are truly everywhere in our electronic world. From the smallest gadgets to the largest appliances, they play an indispensable role in making our modern lives convenient and efficient. Section 9. Importance in power supply systems. In power supply systems, capacitors play a crucial role. They are essential components that ensure the stability and reliability of the entire system. Capacitors help stabilize voltage and current, which is vital for maintaining consistent power delivery. This stabilization prevents fluctuations that could otherwise damage sensitive electronic components. This is important for the proper functioning of electronic devices. Without capacitors, power supplies would be less reliable, leading to potential malfunctions and reduced lifespan of electronic equipment. Capacitors filter out noise from the power supply. This noise, if not filtered, can interfere with the operation of electronic circuits, causing erratic behavior and performance issues. By smoothing out the power, capacitors ensure devices work properly and efficiently. This noise reduction is crucial for high-precision applications where even minor disturbances can lead to significant problems. They also protect circuits from sudden spikes in voltage. These voltage spikes can occur due to various reasons, such as lightning strikes or switching operations, and can cause severe damage to electronic components. In renewable energy systems, capacitors store energy. This stored energy can be used to balance the supply and demand, ensuring a steady flow of power even when the renewable sources are not actively generating electricity. Solar panels and wind turbines generate fluctuating power. These fluctuations can make it challenging to maintain a consistent power output. Capacitors help stabilize this power before it is used. By doing so, they make renewable energy sources more viable and reliable for everyday use. This makes renewable energy systems more efficient. Efficient power management is crucial for maximizing the benefits of renewable energy and reducing dependency on fossil fuels. Capacitors are also used in power factor correction. Power factor correction improves the efficiency of power transmission by reducing the phase difference between voltage and current. They improve the efficiency of power transmission. This efficiency leads to reduced energy loss, which is beneficial for both the environment and the economy. This reduces energy loss and saves costs. Lower energy loss means lower electricity bills and a reduced carbon footprint. In power supply systems, capacitors are indispensable. Their role in stabilizing, filtering, protecting, and storing energy makes them a critical component in modern electrical and electronic systems. Section 10, Future of Capacitor Technology. The future of capacitor technology looks bright. Researchers are developing new materials to improve performance. These materials can store more energy and charge faster. This will make capacitors even more useful. Supercapacitors are a new development. They can store much more energy than traditional capacitors. They also charge and discharge very quickly. Supercapacitors could replace batteries in some applications. Flexible capacitors are another innovation. These can be bent and twisted without losing performance. This makes them ideal for wearable electronics. They can be integrated into clothing and accessories. The continuous improvement in capacitor technology will lead to new applications. From faster electronics to better renewable energy systems, capacitors will play a key role. Section 11. Summary and key takeaways. Capacitors are vital components in electronics. They store and release electrical energy quickly. This makes them different from batteries. Understanding their basic structure and function is simple and important. Capacitors consist of two plates and a dielectric. They charge and discharge rapidly, storing energy in an electric field. This rapid energy release is useful in many devices. From smartphones to power supplies, capacitors are everywhere. Their applications range from smoothing out power to improving sound quality. The future holds exciting developments in capacitor technology. Supercapacitors and flexible capacitors will bring new possibilities. Capacitors are small but powerful. They play a crucial role in our electronic world. Understanding them helps us appreciate the technology around us.